Aloha! Welcome to Lessons from Math Camp. I'm Dane, and today's lesson is why radians? I can think of 3 reasons. But first, a quick reminder. What is a radian? 1 radian is defined as the angle, theta, subtended from the center of a circle which intercepts an arc equal in length to the radius of the circle. You can think of this as taking an equilateral triangle and squeezing 2 of the legs a little bit till it bulges on the other side. Since 6 60-degree angles fit in a circle of 360 degrees, and a radian is a bit less than 60 degrees, slightly more than 6 radians are in a circle. Actually, since the circumference of a circle is 2 pi r, then the number of radians in a circle is exactly 2 pi. First, let's look at some proportions. Part is to whole, as angle is to circle. As degree of theta is to 360, as the radian measure of theta is to 2 pi, as the arc length of the circle is to the circumference, 2 pi r, as the sector area of the circle is to the area of a circle, which is pi r squared. Now let's take 3 of those expressions and play with them. I'm just going to rearrange them a little bit, and we'll look at the 2 on the left, cross multiply. The arc length, which I've abbreviated as L, times 360 will be equal to 2 pi r times the degree measure of theta. And then if you divide by 360 and simplify, the length of the arc is going to be pi over 180 times r times the degree measure of theta. Looking at the 2 expressions on the right and cross multiplying, we get the arc length times 2 pi equals 2 pi r times the radian measure of theta. So now the arc length is 2 pi r times the radian measure of theta divided by 2 pi, which is L equals r times the radian measure of theta, familiar to a lot of students as L equals r theta. Which would you prefer to work with? Next, let's play with the area. I've rearranged 3 of the expressions. Take the left 2, cross multiply. The area times 360 is going to be equal to pi r squared times the degree measure of theta. Divide by 360 and simplify. The area of the sector is going to be pi divided by 360 times r squared times the degree measure of the angle. Using the right 2 expressions, cross multiplying, the area times 2 pi is equal to pi r squared times the radian measure of theta. So the area is equal to pi r squared times the radian measure of theta over 2 pi. Canceling off, we get the expression area equals 1/2 r squared times the radian measure of theta, otherwise known as 1/2 r squared theta. Neat, huh? So the first reason why radians is that most formulas involving angles are a lot less cumbersome in radians and therefore much easier to remember. Next, let's take a look at graphing trigonometric functions. This particular program is GeoGebra. Okay, let's graph y equals sine x. We're in radian mode. Look at this, really nice. 1 on the vertical axis, 1 on the horizontal axis, they match. Oh, let's change that to degrees. So sine of x in degree mode. It kind of looks kind of flat. Is that really a sine wave? Oh, maybe, you know what, the scale has to be fixed. So I have to
go down to the the x-axis, and I have to get everything so that it shows up. Oh, there we go. Yeah, that makes a lot of sense. Look at this is 1 and this is 100. Great.
Reason 2, y radians. Since an angular measure of 1 radian corresponds to a linear measure of 1 unit on the unit circle, the natural scale for graphing is 1 to 1.
And for those of you who want to do a little calculus, let's see. The limit as x goes to 0 of the expression sine of x divided by x is 1, of course. Well, maybe. Let's suppose that we want that in degrees. The limit as sine x over x degrees as x goes to 0. Let's see. Oh, of course. That's 180th times pi.
So reason 3, y radians. That means when you take the derivative of the sine function, you end up with pi over 180 cosine x instead of simply cosine x. As my friend Lynn McMullen says, who needs that? So a quick recamp. Y radians? Well, why not?